This is the brief on fluid dynamics continuity equations. All right, so you can kind of think of these equations as the core operating manual for anything that flows. They're what give us that essential link between mass, motion, and, the forces acting on them. So let's break it down into the three key pieces you really need to get. First up is mass continuity. And this one, well, it's really all about conservation. It's basically saying that mass can't just be created or destroyed, right? So any change you see in a fluid's density over time, that has to be perfectly balanced out by what we call the mass flux. And that's really just the net flow, density times velocity, moving through the whole system. Second, we've got momentum. And if you think of mass as the fuel, then momentum, that's the engine driving the flow. It's this really powerful, dynamic link between mass and motion. The big takeaway here is that momentum transport acts like this concentrated, fast-moving surge inside the fluid. And that's the fundamental thing that governs how the flow behaves overall. And finally, there's the Cauchy Momentum Equation. This one's all about how fluids accelerate. The equation basically tells us that a little particle of fluid will speed up or slow down because of two things: external forces, think gravity, and these really crucial internal forces. And those internal forces, which we call the stress tensor, are pretty much all the friction and pressure that's pushing and pulling inside the fluid while it's moving. So if you get these three core principles, mass conservation, momentum transport, and how forces are applied, you've got the exact blueprint you need to predict and analyze the movement of pretty much anything that flows.